everyone. Welcome to my channel. Myself Shreyas T. I am studying in Sri Venkateswara College of Engineering, Department of Mechanical Engineering. Today we discuss the topic about the environmental engineering on a vector calculus. Let us see one by one. Environmental engineering, a vector calculus perspective. Explore the synergy between environmental engineering and vector calculus. This presentation highlights how vector calculus aid in modeling environmental phenomena. Learn how to apply mathematical tools to solve real-world engineering challenges. Vector calculus. Quick review. A brief review of essential vector calculus concepts: gradients, divergence, curl, and vector integration is explained. Let us understand the foundational mathematical tools. These tools are crucial for modeling environmental processes. First one is gradient. It describes the direction of the greatest rate of increase. Second one is the divergence. This measures the outward flow of the vector field from a point. Third one is curl, indicates the rotation of a vector field around a point. Next is fluid dynamics, modeling water flow. Use vector fields to model water flow in rivers and pipes. Governing equations, Navier-Stokes and continuity equation. These equations help analyze fluid behavior and predict flow patterns. First one is the Navier-Stokes equations. It describes the motion of the viscous fluid substances. Next, the second one is the continuity equations. It expresses the conservation of mass in fluid dynamics. Next is air pollution dispersion modeling. Apply vector calculus to model air pollutant dispersion. Use wind velocity fields to predict pollutant movement. Gaussian plume model and advection diffusion equations are crucial. The first one is the emission source, pollutants released into the atmosphere. Next, second one is the advection, transport of pollutants by wind. Next, third one is diffusion, spreading of pollutants due to concentration gradients. Next is the heat transfer in soil analysis. Let us discuss how the heat transfer in soil analysis. Vector fields applied to temperature gradients in a soil. Fourier's law of heat conduction is essential for this. Model geothermal energy extraction and soil remediation. Solar radiation heat input from the sun. Next one is the conduction. Heat transferred through soil. Third one is the convection. Heat exchange with the atmosphere. Next is the groundwater flow. This is Darcy's law. Darcy's law and vector potential in groundwater flow. Hydraulic conductivity has a tensor field. Model contaminant transport in aquifers using these principles. First one is the hydraulic gradient, driving force for groundwater flow. Second one is the Darcy's law, relates flow rate to hydraulic gradient. Third one is the aquifer, underground layer of permeable rock. Next we discuss about the coordinate transformations. Use coordinate system and transformation for environmental modeling. Cartesian, cylindrical and spherical coordinates help simplify complex problems. First is the Cartesian, simple for planar surfaces. Second one is cylindrical, ideal for pipe flow. Third one is spherical, suited for global models. Next we discuss about the real world application of this vector calculus. Explore the real world examples of vector calculus in action. Case studies on pollution control. and resource management. First one is the water treatment. It optimizes chemical dosing. Second one is air quality, model pollutant transport. Third one is the soil remediation, design efficient methods. Let us conclude this by conclusion is recap the power of the vector calculus in environmental engineering. We can use the vector calculus in our surrounding environment also. Vector calculus provides essential tools solving real world environmental challenges that depends on these tools. First one is the modeling. This simulate environmental processes. Second one is the optimization. Improve engineering designs. Third one is the prediction. Forecast environmental impacts. Thank you for the watching this video. Please like and subscribe. Thank you.